My dear students, today I am going to explain few problems on alternating current basics. Okay, the first question: the electric mains in a house is marked as 220 volts and 50 hertz. This is given. What is the equation for instantaneous voltage? Then first you need to find the equation for instantaneous voltage. First you should know the relation. So here this 220 volts power supply is nothing but when this is given ERMS. E means electromotive force. ERMS is how much? 220 volts. So there are four types of voltages are there now. Peak value of the EMF, peak value, and instantaneous value, and mean value, and RMS value. But when the sticker is given on the mains, what is this value? Whether you consider it as peak value or something? No, it is RMS value. RMS value of the AC current given to your house is given. Its frequency is also given, which is 50 hertz. But what is asking? What is the equation? You know already equation for instantaneous voltage is E is equal to E naught sin omega t plus phi. This is called initial phase. This is angular velocity. This is time. Now this is the relation. You know already the instantaneous EMF at any instant of time is equal to peak value of the EMF sin of omega t plus phi. Sometimes you need not write phi, but I am writing phi here. If the initial phase is there, then you write phi. Otherwise, you need not write it. Now he is asking equation now, so I am taking complete equation. You need to rewrite the equation. But how can you write this? Here frequency is there, but in the place of omega, you know, indirectly he is telling omega is nothing but 2 pi f. Omega is nothing but 2 pi by time period. 1 by time period can be written as frequency. So that's why this is 2 pi f. And one more thing, electromotive force, RMS value of the electromotive force is peak value divided by root 2. That means in the place of E naught you can write ERMS into root 2. So that's why E is equal to E naught ERMS, RMS value of the voltage into root 2 sine of 2. So here you can write omega is nothing but 2 pi f into t plus phi. Now E is equal to E RMS value is how much? 220 volts into root 2. Next you write sine as it is. 2 pi f, 2 into pi. F is how much? 50 frequency into t plus phi. Now you can write, finally you can write this equation as 220 root 2 sine of 250 is 100 pi t plus phi. This is the required equation. He is asking by using these values, find the equation for instantaneous voltage. Instantaneous voltage at any instant of time t is 220 root 2 sine. That means if you know the t value, you can find the instantaneous voltage. This is the required formula. I hope you understood this. Now second question. An AC is given. AC means alternating current. So if I am not using the word AC current, you can immediately understand it is AC current only, alternating current. If I am talking about the electromotive force of AC, I will use it. If I am not using whether it is electromotive force or current, you immediately understand it is AC. And AC means alternating current. And AC is given by I is equal to 5 root 2 sine 150 pi t by pi by 4. Then give the frequency and RMS value of a current. So if you see here, equation of instantaneous current is given. I means instantaneous current. You know it. I naught is peak current. You are going to write the solution. First you write the given values. Given equation is how much? I is equal to 5 root 2 sine 150 pi t plus pi by 4. Now you know already one ready-made equation. Instantaneous current in the AC circuit is I into I naught sin omega t plus pi by 4. Just to compare here. He is asking, then give the frequency and RMS value of the current. Frequency means what? F, but you don't have F here. So you need to write this equation such a way that you need to get omega as 2 pi f into t plus pi by 4. So actually this is, you can be written as phi value. So this is phi. Now what is asking, what is the frequency value? But you compare this 2 pi ft. But here 2 pi ft means pi is okay, t is t, okay. But in the place of 2f, you have 150. So indirectly is giving 2f is equal to 150. Therefore, f is equal to how much? 150 by 2. 2 if you bring, it becomes 75 Hz. Now what is asking? What is the RMS value of the current? You know, here in the place of I naught you have 5 root 2. Then you know I RMS, if you want to find out, I naught by root 2. I RMS is also called virtual value, IV. I naught is how much here? 5 root 2 divided by this root 2. Then it cancels. So RMS value or virtual value is how much? 5 amperes. So he's asking, what is the frequency? Frequency is 75 Hz. What is RMS current? 5 amperes. That means by using this known equation and comparing this known equation with the equation given in this, you can find the values. I hope you understood this. Now I am going to explain third problem. A voltage of E is equal to 100 sin 314 t. Voltage symbol you can write it as E also, E or V, because voltage or EMF both are same. A voltage of E equal to 100 sin 314 t is applied across a resistor of 25 ohms. What is the reading of RMS value of a current? So when measured with AC ammeter, first answer. When measured with AC ammeter is used for AC current. So normal ammeter is different, that is used for DC. But AC ammeters are actually hot wire elements, hot wire ammeter. Because the heat energy produced in the wire is independent of the direction of the current. In the AC, the current direction go on changes, but the amount of heat energy produced is independent of the direction. That's why instead of using the normal ordinary moving coil ammeter, we should use hot wire elements to measure the AC ammeter and AC current and AC voltage. Hot wire instrument, these are called. Now if you go for first answer, when measured with AC ammeter, what is the RMS value? But what is this is actually indirectly in this equation, this is E naught value is given. E naught value is how much? 100 volts. But he is asking what is the current, RMS current. He is asking reading of the RMS value of the current. So RMS value of the current, if you want to find out, first you should know RMS value of the EMF is, you know, peak value divided by root 2. You know the formula, E naught by root 2. E naught is how much? 100 divided by root 2. This is actually ERMS, but our goal is to find the IRMS. IRMS is nothing but ERMS divided by resistance. You know, I is equal to V by R formula. V is nothing but electromotive force. So root means square value of the electromotive force divided by the resistance will give you current. So ERMS is how much here? 100 by root 2 divided by resistance is how much here? 25 ohms. ERMS and divided by 25. Then 25 fours are. How much it is? So 4 by root 2, definitely you will get the 2 root 2. 2 root 2 amperes. This is IRMS, RMS value of the current when you measured with AC ammeter. But when you measure with the ordinary moving coil ammeter, this is used to measure only DC currents. So when you use this ordinary moving coil ammeter to measure the AC current, it will give you 0 reading. So answer is for B, it is 0 amperes. It cannot show you the value because the current in one direction and current in other direction gets cancelled and it will show 0 reading. But we are using hot wire element in the first case. Even though direction of the current is changing, but RMS value, to measure the RMS value, we use it because the hot wire element is independent, depends on heating effect of electric current. So that's why we use this. But here the charge flowing, moving coil ammeter, normal moving coil ammeter always uses the amount of charge flowing in one direction, amount of charge flowing in another direction for first half cycle and the second half cycle, the average becomes 0. That's why it always shows, even though current is there in the circuit, but this ordinary moving coil ammeter will show you the 0 reading. That means it cannot be used to measure the AC current. I hope you understood.